Now that we've set up LDAP on all three systems, including the primary server, SUSE Enterprise 10, secondary server, Red Hat Enterprise 5, and the tertiary server, Solaris 10, let's return to the basics of LDAP by focusing on the extension of, or the continuance of, our directory information tree using the LDAP add online utility. So let's open our graphic to the directory information tree to discuss where we left off. We've created the base DN, DC equals Linux CBT, comma, DC equals internal, and 3 top-level organizational unit containers to house users and groups for various purposes, including people, engineering, and sales. We've also created one user in the people OU, and we'll continue by building the other users. So let's navigate to our documentation. And we'll be focusing on LDAP add. LDAP add features adding objects to the directory information tree. So facilitates the addition of objects to the DIT under your server's auspices. In actuality, LDAP add is a symlink to LDAP modify. Let's just indicate LDAP add. What you actually execute from the command line is really a symlink to LDAP modify, which tells us that whatever LDAP add can do, LDAP modify can do as well. So note, LDAP modify performs the same functions as LDAP add. So that's something to keep in mind. You can consolidate your efforts to one tool as a result. Now the default invocation reads from standard in. Default invocation reads attributes from stdin. So if you indicate LDAP add with the appropriate authentication credentials to the LDAP server without specifying a file or the addition on the command line, you'll be prompted on standard in to supply the addition to the directory information tree. So keep that in mind in the event that you neglect to specify the value or values to be added to the directory information tree. Now let's define our first set of tasks, including add users to remaining OUs. And the syntax, of course, will begin with LDAP add. All of the syntax will be between single quotes, so omit the single quotes if you are following along. Don't indicate the single quotes unless you're protecting a value to be added, such as a distinguished name. So back to our graphic for a moment. We've already created a user named LinuxCBT1, in fact, in the people OU. An LDAP search will confirm as such. Let's find an LDAP search window. And here we're on SUSE 1. Let's see if we've got LDAP search in our history. And it isn't, so let's navigate to a box where we do have it. Here it is. And an execution of LDAP search and this is still on SUSE 1, not SUSE 2. So if we indicate the hosts, LinuxCBT SUSE 2, the anonymous dump reveals that there is a user named with the common name, CN, LinuxCBT1, already created. So this LinuxCBT1 user is the user we have named here as LinuxCBT. We could have named the user LinuxCBT, but just for the sake of being able to increment uniquely, we tacked on the 1. So now we'd like to create, in addition to the groups that we will create, other users in other OUs. So let's focus on the engineering OU for a moment. Let's create a similarly named user who belongs to this OU. So our first task is to create a username linuxcbt1 in a different OU. So add user linuxcbt1 to remaining OUs, which means we'll ultimately end up having 3 users named linuxcbt1 to drive home the point that you can have redundant usernames or common names so long as they're in different containers, different organizational units. So what is the command sequence like? Well, the command sequence mimics that of all of the other online tools, LDAP search, LDAP add, modify, delete, etc. And that is, we need to indicate the user with which to bind to the directory information tree or to the LDAP server. That is specified using LDAP uppercase D. So in between double quotes, we'll indicate the user with which to bind to, and we'll always use this user unless we make a change or modify the ACLs to permit other users to make changes to the DIT. The CN is manager, or the common name. This is the built-in user who does not appear when you do an LDAP search because it's configured in slapd.conf. This is the super user, the equivalent of root in the Linux or Unix environments. So CN equals manager, DC equals linuxcbt, DC equals internal. This is the user with which we'll bind all the time to the DIT unless we make an ACL change. And even if we make an ACL change, the user named manager will still have access unless we update slapd.conf to change the name of the user to something else, such as LDAP admin or so on. So we need to indicate who we bind as. We should also, since we currently don't have SASL or TLS enabled, we should use simple authentication. That's indicated by specifying the lowercase x option. This allows us to authenticate simply or without using SASL, which we currently do not have set up. We need to also indicate whether or not a password is to be specified on the command line or prompted on standard in, which is not echoed to the user. If we indicate uppercase W, we achieve that effect. Now, without indicating a file, this will prompt us on the command line to supply the new user. Let's try it. So let's just note prompts on stdin for values, 1 or more, of course. So we could add 1 or more objects, and they can be of any type supported by the organizational unit, not necessarily restricted to users. So if you can sort of commit to memory this syntax, the LDAP command, whether it be add, modify, remove, etc., or delete, dash upper D, followed by the user with which to bind to the directory, followed by optionally lower X for whether or not you have SASL turned on, followed by upper W, then you'll be prompted on the command line, then optionally lowercase f if you have a file that you'd like to reference. So our task is to add this new user. Now let's try it from the shell. Now, if we try to connect from our portal system, SUSE1, we'll need to indicate the name of the target LDAP server. Otherwise, we run the risk of LDAP add defaulting to the local system. So we do so by indicating host linuxcbt SUSE2. This connects us to the remote system. Or we run the add from the remote system. Either or will do. We'll indicate the password. This is the password configured in slapd.conf for the manager root DN user. And now notice that LDAP add is waiting on standard in for us to add an object to the directory. Now we can copy verbatim this dump you see here from LDAP search and paste it in and see whether or not LDAP add will allow us to add the same user or a previously defined user to the same OU. Or we can create a new user altogether. Here is the original user edition that we saved. This is what's echoed by LDAP search. We can take this and simply update the OU to be something else. But let's, for the sake of it, try to add a user to the same OU with the same name. Now, once you've finished supplying entries, execute Control-D. That is the way you signal on standard in to the process that's waiting that you've completed input. Notice the error returned. LDAP add already exists 68. If we echo the exit status, we see it's non-zero. It's in fact exit error 68, which means LDAP did not commit the changes to the directory information tree. So back to our shell for a second, or back to our text. If you try to add a duplicate user, the DIT will deny the entry, as we've seen, with an error 68. But a slight change to the user object will suffice. Updating, for example, the distinguished name to Linux CBT2, the common name to Linux CBT2, and optionally other attributes which contain the string Linux CBT1 to 2. Optionally, because mail can be shared, or mail does not have to be unique, but the distinguished name and common name items must be unique. Let's update it for consistency. So now we'll add a second user by making a simple change and try again on the command line. Now this will add again from our client to the remote server because we've specified -h. Now if you insist on making the changes without being prompted on standard in for a password, use lowercase w followed by the password, either immediately juxtaposed with no space, such as the following, or a space and quotes, double or single quotes, to separate or to protect the password. This will allow us to authenticate without being prompted on standard in. Now notice LDAP add is waiting for us to specify the new entry. Control D, and notice the value return adding new entry. Also notice that LDAP add has not dumped us to the command line, to the shell. It is allowing us, or waiting for us, to supply additional entries. But this new entry has been added. If we try to re-add it, it'll fail. Control-Shift-V, Control-D, the user already exists, and because user already exists, it causes LDAP add to terminate, to exit. So let's just note supply LDIF info for creation of user object on standard in, and then execute Control D when complete. And of course, always follow up with an LDAP search to be sure. So confirm results with LDAP search to be sure that the recently added entry or entries have been committed to the DIT. Let's find a recent invocation of LDAP search using the shell exclamation prefix, which references the most recently invoked instance of the command. And now notice that there are 6 entries, Linux CBT1 as well as Linux CBT2. Both exist in the people OU, and ditto if we add additional users. Now how about wholesale additions? We want to add, let's say, 3 more users at one time. Well, there are multiple ways to do it. Take your skeleton, take this LDIF skeleton, and variabilize it in a process such as a Perl script, and you'll be able to generate multiple items on the fly, or modify it manually. So let's add Linux CBT3, and then we'll just copy the entire block, paste it, indicating 4, and then terminate with one final entry indicating user 5. So long as the common name and distinguished names are unique, you should have no trouble adding these entries to the DIT. With that said, let's copy this entire block into memory, as we'll add the 3 users from standard in. And again, this can be performed from any host, whether from Solaris or the local system. Either or will take, or even from the Red Hat system. Since we've been adding from the portal box Linux CBT SUSE 1, that's this system, or this system here, let's try adding from one of the slaves, the Red Hat Enterprise 5 box, which we should have open in this window. We'll need to execute LDAP add, connect using cn equals manager. Again, this is the root DN user. DC equals Linux CBT, DC equals internal. Followed by simple authentication, as well as a prompt for the password, which is optional, but for the sake of the password not remaining in the history of the user's shell, force the process to prompt you on the command line. That way, the password will leave no traces, or the entry will leave no traces in the user root's bash shell history. We should indicate the host. If we try to add to the local hosts, in fact, let's go ahead and try that just to show you what would happen. So this will prompt us on standard in once we've indicated the password. It's waiting for us to supply our 3 entries. We'll Control-Shift-V, there are the 3 entries. And notice after each object, we see, after the N, for example, adding Linux CBT entry 4, and we also see the 3 entries blew by. Let's Control-D to terminate. Now we see Linux CBT 5. And then let's go ahead and execute an LDAP search just to recap exactly what happened. There's our LDAP search. Now we see that there are 9 entries. Let's scroll up and confirm the entries. Starting from the top, 1 was created as a single instance, ditto for 2. However, 3, 4, and 5 were supplied in one swoop. Now, just to clarify why we didn't need to specify the name of the primary server, let's just note. So our second task was to add users Linux CBT 3, 4, to the DIT wholesale via standard in from slave server. So we executed our LDAP add, and let's just take that command again and list it as step A. However, notice we did not indicate the -H option, the host option. However, the entries were still added to LDAP. This is one of the beautiful things of LDAP, in that once you have your slapd configuration set with the update reference, the LDAP clients executed on a host that participates in replication knows exactly where to send the LDAP client request. So note, the slave server auto-redirected the LDAP add request to the primary server. And then, within seemingly a blink of an eye, because we did execute LDAP search almost immediately after, we were able to query the results from the secondary server. We know it's from the secondary server because LDAP search was not instructed to query the primary server. When you don't explicitly specify the primary server with respect to read operations, the utilities default to the local host. So in this case, the search executed against the local host, which happens to be a slave host. So graphically, let's explain what happened. We've got three systems participating in replication. The primary LDAP server, which runs SUSE Enterprise 10, and its name is Linux CBT SUSE 2. One slave server named Linux CBT Serv 4, which happens to run Red Hat Enterprise 5, and a Solaris 10 box, which is also a slave server. We have an SSH session open to each of these boxes. We connected to the Red Hat box and executed LDAP add without specifying that the changes are to be made to the master server, the server that controls write operations to the DIT. But because each slave server has the appropriate update reference in each server's slapd.conf, they know to redirect any LDAP write request to the appropriate DIT master. How do we know that? Well, let's take a brief look on the secondary server, the server's LDAP or slapd.conf. A less of slapd.conf, and if we navigate towards the bottom where we made the changes, reflects the update reference variable that I'm discussing or referencing. This variable, when defined, redirects, unbeknownst to you, the client or the caller, the request to make a change to the DIT, which means a write, to the server responsible for the DIT, which is the master server. The others are just slave servers. They simply are replicas. They simply allow read operations. So let's just note this etc open LDAP slapd.conf entry cause the LDAP add write request to be redirected to the DIT master, which happens to be in our particular case named Linux CBT SUSE 2, which is running SUSE Enterprise Linux, but the distribution is irrelevant. OpenLDAP works across the board in a similar fashion. So, with that said, we can make changes from any of the slave systems, and they get propagated immediately to the DIT and then back to each of the slaves because of the slurpd replication. Again, LDAP search told us that the results were replicated to the local system. And if we execute the LDAP search against the primary server Linux CBT SUSE 2, we'll see a similar result. Let's take a look at one of our windows here, where we should have Linux CBT SUSE 2 open. And in neither case, either option is open. So what we can do is alternate the LDAP search command to search the DIT master specifically. In this case, it is searching that host specifically because the -h option is enabled. Let's just take this command and paste it into our notes. This forces LDAP search to query the DIT master in our particular environment. Simply the -h option. So with that said, know that if you execute the -h option with any of the LDAP online tools, it'll cause the tool to reference the host indicated on the command line. And know that you have the flexibility of, because of the update reference variable, of making changes from any of the systems that participate in the LDAP directory information tree. And know that the changes will be propagated through the appropriate master or the appropriate server responsible for DIT writes. Now, what does our DIT currently look like? Well, LDAP search tells us that there are 6 entries. We've got Linux CBTs 1 through 5 defined, plus the other 3 objects, the organizational unit objects, for a total of 9. And on the primary, a quick refresh should reveal as such, and there it is. Just had to give slurpd a second to move the changes over. So 9 entries on both the primary and secondary servers. Now, how about looking at the DIT from a graphical perspective? There are certainly many LDAP graphical tools out there, both proprietary and open source. SUSE Linux comes with the LDAP browser, which is built in and allows us to view and interact with the DIT. If we navigate into our YAS window, in fact we still have it open here all this time, and simply click on reload, it'll reconnect to the DIT, and at this point it's been open too long, so let's go ahead and close it and reconnect. This will bring up a new instance, causing us to authenticate. We want to connect to Linux CBT SUSE 2, cn equals manager, dc equals Linux CBT, and dc equals internal. And now we see the base DN again, and when we expand it we now see 3 organizational units: people, engineering, and sales. When we expand people, we see the 5 users, and we can focus in on any user. Notice that each user is referenced not by the full path or the full distinguished name, but by the relative distinguished name. cn equals Linux CBT1 is relative to the organizational unit people, which is also relative to the base DN of Linux CBT internal. So rather than displaying or redisplaying the full hierarchy each step of the way, which can become convoluted, simply the common name, which is unique on a per user basis within a given OU, is displayed. If you click on entry data, you will see the fields that have been populated, as well as all of the other fields supported by the schema that constitutes the particular object. This is perhaps the easiest way to become familiar with the fields supported by a given schema, as opposed to using a text editor to study the schema files. Use a graphical browser like the LDAP browser. Here you see the fields we've completed, but there are many other fields: audio, pager, given name, and so on. Take given name, double click, and you can supply a value. Let's call this user Linux CBT1. Click on OK, and now that user will have that object once we save it, or that attribute value once we save it within the object. Also notice above, once we've drilled down on a particular user, the full path is displayed. Let's just make some notes before we fly too far ahead. So another task is to use LDAP browser to view entries, to view DIT, and to make changes, which basically is the same as using LDAP add. Also note, LDAP browser is an easy way to learn the attributes supported by various schemas or object classes. Using the LDAP browser, you can build LDIF files. You simply indicate the attribute name followed by a value. We can build a user, for example, with every single field defined from a text file by simply indicating the field name and the value. Now, these settings haven't been saved, or this attribute update has not been saved. We know that because we haven't clicked save, and also we can confirm it from the shell by using LDAP search. And we'll see for the user Linux CBT1 that there is no defined attribute for the given name. There is no given name. However, if we save it, this performs the equivalent of an LDAP add, which is really LDAP modify with the add option. And then if we re-enumerate and scroll to the user Linux CBT1, we'll see the new attribute for the given name. And there it is, given name. And similarly, we can delete it, but we dedicate an entire section to using LDAP delete. So, of course, the browser makes it much, much easier. But if you understand what the browser really does under the hood, which is basically calls to LDAP modify for add, modify, and delete operations, then using the GUI is a piece of cake. So we've updated that attribute. We can go back to the tree. We see the tree we've yet to populate: OU engineering, OU sales. So how about creating the entries before we move on for engineering and sales? How about creating the same users in those two OUs? Certainly our tree doesn't reflect so many users. If we take a look at the tree, we have definitions for one user per OU and one group for two of the OUs, but we can extend this. So let's navigate to our gedit window where we have the three users defined. There they are. And we will add these users to the two other OUs by simply updating the OUs in each case. In fact, we want 5 users. So let's define this twice more and then double it up. And we'll just save this as one large file, or relatively large file. So this becomes 1, and this user becomes 2. Now all of the OU equals people need to change. So rather than changing each step of the way, let's do a mass replace. Wherever OU is equal to people, change it to OU is equal to engineering. Four replacements were made. OU equals engineering for users 1, 2, 4, and 5. That means we're missing one user. Let's insert 3. And by the way, the order doesn't matter. So we could specify the users out of order. Has no impact on whether or not the user will be populated into the DIT. So now we have 5 users for OU equals engineering, and if we want everything to truly be in one file, copy the contents to a separate file and make a wholesale change. Now we'll replace using Control R. Wherever OU is equal to engineering, set it to sales. Five replacements, which is what we expected. And now let's copy the changes from here and paste them into the original document, perhaps towards the end, since graphically the sales OU is to the right of the engineering OU. So now we have one document with 10 users to be added. Let's save this document in our LDAP directory as add 5 users to engineering and sales OUs. So we know exactly what this document does. With the suffix of LDIF. The suffix is unimportant. It simply tells us visually the purpose of the document. But as far as the OS is concerned, it doesn't matter. So long as the file is text, LDAP add or modify will process it. So how do we add a wholesale? So that's our next task for LDAP add. Let's find our notes. Task 4. Add 5 users to 2 OUs. Engineering and sales via text file. Well, we take the LDAP add command that we've executed thus far and just turn on the -F option, as we alluded to earlier. So all remains the same, but this time we indicate -F followed by the name of the file. The name of the file is add_5 users to engineering and sales OUs.LDIF. We should also indicate the name of the server or the primary server if we intend to add these users from our portal box, because our portal box does not run LDAP. So somewhere in here we'll stick in a -H option, Linux CBT SUSE 2, to indicate that it's to update the primary DIT server. And we're doing this from the local host because this is where we have saved the add 5 users file. Let's go ahead and paste it. So LDAP add, bind to the DN as the root DN, simple authentication, prompt for a password on standard in, connect to the host Linux CB2 SUSE 2, and process the contents of add 5 underscore users to engineering. Now, just to be sure we haven't made a mistake with the file, we'll just erase a couple or a few of the letters from the suffix and just press tab. Pressing tab indicates to us that all of the other characters that constitute the file name are correct as far as the bash shell is concerned, since bash supports tab completion. If the file name were wrong even by one character, such as an underscore or the number 5, etc., the bash shell would be unable to complete the name of the file. Let's try to add this or add these items to the DIT. And now we see the entries 1 through 5 to engineering, 1 through 5 to sales. Let's echo the exit status. It's clean, so we've successfully added 10 users, albeit the names are duplicates, but they're in different OUs. Now, of course, these are simple additions. What if we made a mistake with our input file by having duplicate usernames? How would that impact the process? Well, looking at our add 5 users, supposing we had Linux CBT 4 twice to the engineering OU. A failure here would cause, by default, the LDAP utility to not process this entry. And there are ways around it. Later on throughout our studies, we'll look at the option which allows us to skip errors. So if there's an error, skip it and just move on with life. Now let's see what LDAP search has to say about the state of the DIT, the state of the nation. The state of the DIT is as follows. There are 19 entries. So the OUs have grown. How about LDAP browser? Well, before we look, let's just list, confirm results using LDAP search as well as LDAP browser. Let's reload. OU has 5. For OU equals people has 5. OU equals engineering. And the sales OU all have 5 users. So we now have 15 users defined, further expanding our directory information tree. We've yet to add groups, but nonetheless, we've added wholesale users. If you've got tens, hundreds, thousands of users to add, if you can somehow script out a process which takes the users and adds them, then that's the way to go. If the users exist in an etc password file or multiple etc password files, there are scripts that are already written. Later on in our studies, we migrate from etc password environments or traditional Unix, Linux user account databases into an OU within a DIT. Now with that said, next we will focus on using the LDAP delete utility. We've created 15 objects, so we should become familiar with deleting them as we have with adding them.